In this video, I'm going to show you how to assemble our first music device. So this music device is going to have our feather board with the ESP32. It's going to have 4 buttons that we can read from and change the color of, and it has a slider that we can read the value from and also change the color of. So the next thing we need to do is to get all of our parts together so that we can start assembling our board. So to get started, we need to have our feather board, our microcontroller here. We should have our base plate, little key spacer, 4 of the keycaps, and we also need to have 4 of these key switches, which are going to fit in here. We should also have our Neo slider, the Neo key board, as well as some of these nylon screws. So the idea of this base plate is it's a modular base plate that's going to allow us to connect a variety of different boards to our microcontroller. So the first ones that we're going to be starting with are the Neo slider, which is going to allow us to have a fader, and the Neo keyboard, which is going to allow us to have 4 keys attached. So we're going to need to also have these 2 cables here. These are called QT cables, and basically they're going to be carrying the I2C data between our microcontroller board and the QT add-on boards. So basically when these cables, we're going to plug these into our feather board here on the bottom, and these have power, ground, serial data, and serial clock. So that is how we're actually going to connect to our other boards. So we don't need to do any soldering at this level. If we want to do some soldering later, we're going to be able to. But for now, we're just going to be able to hook these up using those cables. So there is one little bit of prep that we need to do. So each of these QT boards has their own I2C address. So basically when we connect these boards together, we need to tell the microcontroller which address each of these boards has. So for example, we're going to connect the cable here, and you'll see there is a flat side that's just a little bit longer, and then there's this side with the pins, and you can see there is a longer side there. So what we want to do is to match those up and then just kind of gently but firmly push those in. I find for connectors, disconnecting a little bit of a wiggle often helps, and you just want to feel that that comes in nice and snugly. You want to try to avoid putting too much of a sideways motion on this because it's possible you could break off this connector. If we want to remove it, you can see there's these little tabs there, and what we can do is just kind of get in there with our fingers and pull. And again, I find a little gentle wiggle kind of helps just to ease it out. So again, we can see here there's a longer side in the connector, and there's the flat side on the plug, which is just a little bit longer. And so if we put those together, we can feel that it goes in, and then we can kind of push and just give it a little wiggle until it's snug down there. Okay, so to connect to our Neo keyboard, what we're going to want to do is plug this cable in. So the same idea, there's a exact same connector here, and we've got a long side there, and we want to plug that in. And for these kinds of connectors where they're on the board like that, I like to kind of just hold the connector there with my finger a little bit just to try to make sure I'm not going to tear that off the board. And again, just a little push, little wiggle, and it should feel nice and snug. And you should see here, if we look, that there's just a tiny little gap there. Okay, so we've got our Neo key attached. So one thing we have to do, and we just have to do this once, is we're going to need to change the address on the Neo slider. So it turns out that unfortunately, by default, both of these boards respond to the same address, which is a 0x30 in hex. And for this Neo slider board, what we can do is we can change the address by using these solder pads here. And you can see I've already done it on this board. And what we need to do is we need to go to this one here, this A3, and we're going to need to just gently scratch that connection in there in order to cut that trace. And then that is going to change the address of this board. So let me get a fresh one here. So we've got this Neo slider here. And what we need to do is we need to look on here, and we can see there are 4 pads here, A0, A1, A2, A3. Those make up the address of our board. And what we need to do is actually cut the A3, just the A3 there. And what we can do is we can take our clippers here, and very carefully we can go to the A3 position here and just scratch that out. So you can see here I've got the cutter right in between those pads there, just scratching. And the idea is to actually cut in between there in between the traces to set the address. We just need to do this once. Most of the boards have already the correct default addresses that don't overlap, but with this particular one, we need to do that. So again, what we want to do is find the A3 and then just very gently scratch away that little bit of metal in between those 2 pads to break the electrical connection between those pads. And that's going to change the address so that there is no address conflict. Once we've got that done, well, we can take our other cable and we're going to daisy chain these boards. Daisy chain means to connect one board to the next board to the next board. And basically what's going to happen is we've got our I2C connection coming here to our microcontroller, and that goes all the way through this board and back out to this other connector on the other end. So again, we're going to look for this flat side, which is the longer side. We want to look into our connector and see that one side is a little bit longer there. And we can push and just feel that it's fitting in. If you have it backwards, you can kind of feel that it doesn't want to go in. So again, we want to match the long flat side with the longer section in the connector. And just push in gently, give it a little wiggle until you feel it kind of reach the bottom. And there should be just that little bit of a gap there. Okay, so now we've got that part set up. The next step is to plug into our Neo slider. And we can see here, these are the connectors for the I2C connections. And what we can do is exactly the same thing. We just look for the longer part of the connector, match it with the flat part of the plug. And this one is a little bit more tricky, but basically same idea. Feel that it's in there, just give it a little push and a little wiggle, and it should be in there just nice and snug. Okay, so we've got our 3 boards all hooked together. And so now our feather board with our ESP32 is going to be able to communicate with each of these boards. There's actually a small microcontroller on here. And so basically our feather board is going to be able to talk to this little controller here and ask it what's going on with the buttons and be able to set the status of each of these LEDs. And by asking the Neo slider where it is, we'll be able to get information about where the fader is, and there's also some LEDs on here. Okay, so you can see that obviously this is pretty awkward. So the idea of this baseboard is to have something which can hold all of these boards together. So what we can do is we can start to attach each of these boards to the base plate. So what we're going to need for that is we're going to need some of these M2.5 nylon screws. You could probably also use metal ones, it should work, but these nylon ones are going to basically not damage the plastic, so we should be safe with that. So we'll start with the feather board, and basically I just want to open these up, and you can see there's a couple different lengths of the screws. We've also got some standoffs, and there's also these nuts. The nice thing about this printed base that I've designed and made for you is that these standoffs here that I've printed are actually already threaded. So these standoffs here, just like these ones, already have a thread inside them. And so you can see here with the standoff, I can screw this in, right? And it's going to stay, right? So we can use these to raise our board off of some kind of base plate if it had holes. But here I've actually made things a bit easier. These are already printed with the threads and everything. So basically all we're going to need are the screws. Okay, so which length screws do we need? Well, basically what we want to do is we want to make sure that the screw goes through the board and then has a little bit more depth or travel. And so here where I'm going to screw this board on, if I choose these shorter screws here and put it through, you can see that there's some sticking out on the other side. That should be plenty. That should be plenty. Okay, so what we want to do is kind of lay out where the boards are going to go just to make sure there's going to be enough space. And okay, I tried to bring the cable from here to there. As we could see, it was just a little bit too short. So what I'm going to do is I'm going to take this cable off. And again, what you can do is just kind of grab little tabs and kind of give it a pull and a wiggle. First couple times it might be a bit stiff, so I just kind of held the connector here, grabbed the little tabs with my fingernails and gave it a pull and a wiggle. Again, trying to pull straight out. Don't pull this way because you could lever the connector off. You want to always be pulling or pushing straight along the axis of how the plug goes in. Okay, so I disconnected the smaller cable, got myself this longer cable. Let's go ahead and plug those in. So I had that backwards, it didn't want to go in, so I'm going to flip that over. Got the longer, smoother side, matching the long side in the connector. Now I can feel it's going in, and again, just a little push, wiggle. Okay, so now I got a little more space here. And what you want to do for the feather board is you want to make sure that this USB connector here is pointed out and that these buttons here are on the right-hand side. And we want to put our feather board here in this top position. So what I'm going to do is I'm just going to make sure that these holes in the board are lined up with the standoffs. Going to grab one of these shorter screws and put it in there. Going to grab my screwdriver and just try to get it started. So it might be a little tricky to get it to catch the first time. Also, these are 3D printed parts, so sometimes there may be some small tolerance issues. So it may be that maybe like 3 out of the 4 of these holes might work and one of them doesn't. It's not really a big deal. As long as we've got enough of these to hold down our board, we should be okay. So I've got one in, that's good. Now what I'm going to do is go ahead and grab another one of these little screws. In this case, I'm using the short ones, and screw in the other corner of our board. All right, how much should we screw it in? Well, you want to screw it in until it kind of gets to the bottom, and then just a little bit more, maybe a quarter or a half turn. You don't want to tighten it too much. This is all plastic, so it's not, you can't really tighten it down too much, say compared to metal. Just enough to kind of hold it in there. And I'm just going to put 2 of these screws for now. If I found that it was a bit loose, I could always add in some more to the other corners. Okay, so we've got our first board in. We've got our buttons here on the right-hand side. We've got our USB connection coming out, so our USB cable is going to have some space to come in. And we've got our longer I2C cable hooked up to our Neo keyboard. Okay, so the next step is to screw in the Neo keyboard. And before we do that, we just want to make sure we've got the right side and right direction. And what we want to do is we want to make sure that these LEDs here are on the bottom side and that we can see the top of the LEDs. So each of these is a neopixel LED, and we want to make sure that we can see the neopixel and it's on the bottom. So if you've got it the other way around, no problem, just unplug the cables and flip it around. And if you see these black pieces here and the microcontroller and the connectors, that is the bottom of the board. So the way we can tell which is the top side of the board for the Neo keyboard is we're going to be looking for the holes here, these two holes, which correspond to these two metal pins on our switches. So these are standard keyboard switches, and I chose these ones because they're not clicky, so they're a bit quieter. I think it makes sense for a music device. And the idea is these two pins are going to fit into these two holes, and that's going to allow us to connect to the button. So we want to make sure that we can see down into these two black holes. Okay, so the next step is you may want to arrange the cable just a little bit. If you ever find that you don't like how something's arranged, well, you can just unscrew it and move things around. That's kind of the beauty of this system. So I'm just going to move my cable maybe over here so that it's not sticking out. And I'm going to line up the holes here with the holes in the standoffs. And this one's a little different. We're going to have to add in this spacer. So this spacer here basically is going to help to support these buttons once we plug them in to give them some mechanical support. So we want to line up the holes here with the holes in the standoffs, and we want to line up the holes here with the holes on the board. And then for this, we're going to need some longer screws. So what we can do is go in here and we can look for some screws that are going to fit through the standoff, the spacer I should say, and the board, and go into the standoff. So you can see if I chose this medium-sized screw here, you can see it's only sticking out a little bit, so it's not going to catch. So what we're going to need to do is pick the next longest size. So if I take this one, it looks nice and long. If I stick this through the spacer, you can see I got plenty of space. If I stick this through the board, now you can see I got a little bit of that screw sticking out. So now let's go ahead and screw that first one down. I can kind of look here and match the end of that screw to the hole in the standoff and start to screw that down. And so now you can see that that's pretty good. So I am going to go ahead and grab a couple more of these little nylon bolts and screw those in. You might need to kind of wiggle this around a little bit and then just kind of feel until the bottom of that bolt catches into the standoff. And I'm going to screw that down. Again, I'm going down until I feel a little bit of resistance at the bottom. I can kind of see that the head of the bolt is now bottomed out, and I might just give it like another, say, quarter turn. Okay, so I got two there. It's probably going to be okay. Since these are going to be buttons that we might be mashing, I'm going to go ahead and add in the rest of those bolts. And I'm going to screw that down, hit the bottom, kind of feel it. You can see that reach the bottom there, and then just give it, let's say, another little quarter turn. All right, so I've got my Neo key and the spacer bolted in. I can see the little dot there of the red LED. I can see I've got these two holes there for the switches. Now I could go ahead and add the switches if I want. You can see that there are two metal pins. These are somewhat fragile, so we want to be careful. We want to make sure that these pins are coming out straight. So if it's not straight, maybe you want to give it a little bend. It's possible if you put this in a bit the wrong way, they might get bent, in which case you want to bend it back. And then what I want to do is I want to see that there's these two little sockets here, 1, 2, at the top of the board. And those two sockets match these two pins. And you can see there's also a hole here in the switch, which is going to allow the light from the LED to get through. So what I want to do here is I want to match up these two pins and the hole with the top two sockets and the LED. So let me just put this back down so we're nice and stable. And I'm going to go ahead and take this key switch and put it in. And if it might take one or two tries to get the hang of it, but basically you just want to push it in, again, kind of a wiggle, and you'll feel it comes down. If you feel a bunch of resistance when you're pushing it in, what it may mean is that one of these pins got a little off and that you're bending the pin. So that's something to be aware of. Again, it may happen, but hopefully you get a hang of it as we do these. So again, I'm going to take my key switch, I'm going to flip it over, I'm going to look for the two metal pins. I'm going to match those two metal pins with the two little sockets there, and I'm going to match the opening at the bottom with the LED on the bottom. So then you just want to put it straight in, and again, it's a bit of a push and a wiggle situation, and then what you want to see is that there's no gap here, that the key is nice and snug in there, and then we can see as we can go and we can mash on these buttons, and it's actually pretty stable. All right, so I'm just going to go ahead in and put those last two in. Got those pins, got the opening. Put it in, bam. Got the pins, got the opening. Gently push and wiggle, and we're good to go. All right, so you can see here, this one, see how that's not even like the other ones? So I'm just going to give it a little bit more of a push, and maybe I'll pull it out and see if there's something wrong. Those pins look straight, so it may just be I needed to put it in again, and yep, I just needed to give it a little bit more force. Again, these are 3D printed parts. There may be some slight tolerance issues, but overall, I'd say actually it's been working pretty well. All right, we are almost there. We got our feather mounted, we got our Neo keys mounted, we've got our little address jumper cut there. The next step is to screw down our Neo slider. Exact same process. This time it's just the board we need to screw in, so let's go ahead and use one of the some of the shorter screws. And so I'm going to grab the short ones out of here, line up the holes, and then I'm going to kind of just sort of gently, I'm just like gently turning the bolt and feeling around, and then you should be able to feel it catch, and you should see that it's going in. You want to see that it's going in straight. So then I can screw that one in, and I can go ahead and grab another little screw and get that other side. All right. Great. So now, once I've got this Neo slider bolted down, we've got everything hooked up. Everything's nice and secure. We've got this one piece that we can take with us. Got our nice little Music Devices 3D printed monogram in there. And we've just got one part left for our physical assembly here. We're going to add in some keycaps. So these are 3D printed keycaps. And you can see they've got a little cross there. There's a little cross here. Pretty simple. We're just going to line it up and push it on. Again, some of these might be a little tighter than others, but you can see what we want here is we got the keycap on there, and when we press the key, it goes down, and when we let it go, it comes back up. All right, so just go ahead and finish that. And you can see I kind of eyeball it a little bit and then give it a little feel and squeeze it down. That last one was a little tight, but it's looking good. So we want to see that each of these is pushed in and that they can freely move. Great. Okay, this completes the first round of assembly for our music device. You may ask, what are these other extra standoffs doing? Well, I'm glad you asked. These are ready to receive other kinds of sensors and input devices. So for example, we've got this guy here, which is a distance sensor. It's a laser distance sensor. And this guy would fit down here. And what we would do is if we want to hook up to that, we would just take another cable, we'd come off the end here and hook up into there. We also have, for example, this rotary encoder, which also has a button, and that would fit in here. So those are some possibilities. And we also have all of the design files for the 3D printed parts available, and you are going to be able to actually modify those and come up with your own specific device, which has exactly the inputs and sensors and outputs that you want. All right, this concludes this assembly step. We've got this all ready to go. The next step is to load on the software, which is going to allow us to actually talk to each of these elements.